Hello, sixth graders. Welcome to your video lesson on prime versus composite. So in this lesson, you should be able to determine if a number is prime or composite by using also that you can identify properties of prime and composite numbers. Remember that you should have this written down. Maybe stop and think what you already know to help encourage you and affirm or correct any misconceptions as we go forward. Good luck. Okay, a little vocabulary for you on how do we know if a number is prime or composite. We need to understand what these words mean before we can go and determine if a number is prime or composite. I'm actually going to start at the bottom with factors because factors shows up in the definition of prime and composite. So a factor is two or more numbers that are multiplied together to form a product. So factors are two or more numbers that are multiplied together to form a product. So if you think about forming a product, again, we need to know what that word means. A product is the answer to a multiplication question. So I know that 2 times 3 gives me 6. Therefore, 2 and 3 are factors of 6. If I had 3 times 2 times 5, and I know that that's 30, all of those three numbers are factors of 30. So two or more numbers that are multiplied together to form a product. So what am I using to multiply? So from there, then let's go look at prime. So a prime number is a whole number greater than 1 that has exactly two factors, 1 and itself. So it can only be divided by 1 and itself or only multiplied whole number-wise to get there by 1 and itself. So for example, 3, I can only get to 3 by multiplying 1 times 3 for a whole number, remember. 5 only has factors of 1 and 5. Let's see, 43, I only can do 1 times 3, 43. Prime numbers, so only a whole number that's greater than 1 that has exactly two factors, 1 and itself. A composite number is a whole number greater than 1 that has more than two factors. So similar definition, whole number greater than 1 has more than two factors. So for example, if I think about the number 4, I know that 4, I could do 1 times 4, but I could also do 2 times 2. Say the number 10. I know that I could do 1 times 10, but I could also do 2 times 5. So you see that it has more than one factor, not just one in itself, but also additional ones. So it's a composite number made up of other numbers. And then divisible. When you hear divisible, that means that it is being capable of being divided by another number without remainder. So we can divide all numbers and get parts of numbers, but this means it has no remainder. A lot of times you'll hear that saying it's going in evenly. It's divisible if it can go in there evenly. So I could say that 18 is divisible by 3. That goes in there evenly. It's also divisible by 9, and so on and so forth. So we're going to figure out how can I tell if a number is prime. So when I ask you to determine if a number is prime or composite, how are you going to do that? Well, the trick is that you have to remember, first of all, vocab. We know that prime, it only has factors of 1 in itself. So only 2 factors. So to do that, we are just going to list the factors to check. So for example, if I wanted to figure out the number 6, if I listed the factors, I know that it's 1, and I kind of write that out like this, 1 and 6, and then if there's anything in the middle, 2 times 3, and there's no other ones. But I see that there are more than 2 factors, more than 1 and 6, so this is not a prime number. Whereas I may list 7, and I know that 7 is only 1 and 7, so I list those out. I can't think of anything else. 2 doesn't go into it, 3 doesn't. It's not divisible evenly, so therefore those are prime. So listing factors. The same is true for how to tell if a number is a composite. Again, it has more than 2 factors. So again, I'm going to list factors to determine. So that maybe if I start with 16, I know that 16 is 1 times 16, 2 times 8, and 4 times 4. So that has multiple factors. That is composite. Say the number 2, that is 1 times 2. That's only 1 in itself, so that is a prime number. Fun fact, 2 is the only even prime number, because we know that any other even number is divisible by 2, therefore making 2 a factor. Now, what about 1 and 0, Miss Kroska? What about those? Well, these don't follow those rules. So 1 is only 1 times 1. That's the same digit. And then 0, any number times 0 is just 0, so it's not having any alternate factor other than 0. So therefore, those numbers, you would consider, if they ever come up, they are neither prime nor composite. Okay, on this slide, I'm going to identify all the factors of the whole numbers listed below, and then I'm going to state if it is prime, composite, or neither. So maybe you want to try some on your own. Make sure you are engaging with the video and coming back to check in. 13, so I'm going to list the factors. I know that 1 times 13, so maybe I write that out. It's not divisible by 2 because it's not even. 3 times 4 is 12, so nothing else in there will fit. 32, I know that it's even, so maybe right away, I know because it's even, it's divisible by 2. It's a greater than 2, so it's composite. I forgot to write this one was prime. Follow the directions, Miss Kroska. So listing the factors then, 1 times 32, divisible by 2 with 16. 4 times 8 is 32, and then nothing in the middle. So sometimes I might space it out too much like that and then rewrite. So if you have a better strategy, that's totally fine. So then I can see all of the factors for 32. 19, 1 and 19. I know it's not 2 because it's not even. 3 times 6 is 18, so therefore none of the numbers in between 3 and 8 work in there, so this one is prime. 44, again, is even, so right away I'm kind of assuming it's composite, but I know that's 1 and 44. It's even, so 2 and 22, and then 4 and 11. So those are all the factors, and that's composite. Maybe you're ready to try some on your own. Make sure you do it. 30, again, is even, so I know that's 1 and 30, 2 and 15, 3 and 10. And then notice it's nice because when 5 and 6, they're right next to each other, no other numbers are going to fit. Kind of going down the row, meeting in the middle. Those are composite. 9, that's 1 and 9. This is one people get mixed up for a prime a lot because it has few factors, but still definitely has more than 2. 1 times 9, but then also 3 times 3. So that is a composite. Then notice 0. 0 times any number is going to be that 0. This one's neither, because it doesn't have differing factors as we go through. Here's just a little chart if you want to copy it down or screenshot it, make it your background while we're working on this. These types of lessons of examples of prime versus composite. So reminding yourself we only have 2 factors, 1 in itself when we're prime. Some examples of those numbers are 2, 3, 5, 7, 11, 13, 19, maybe you can, or 17, missed it, you can count. Composite numbers, we remember, have more than 2 factors, and those are here 4, 6, 8, 9, 12, 14, 15, and so on and so forth. And then remembering 0 and 1 are neither. We're going to hit that home so you don't get tricked. To help you determine if a number is divisible by something, this is a divisibility rules chart. This might be helpful. I'd like you to maybe try to copy it down, or if you remember things from another grade level of how you remember something can go into another number, write those down. That'd be great to have on hand. Or again, screenshot, make the back of your iPad as we go through. I will try to remember for you in-person people to have copies of this. So again, looking at it, so just some tricks. would be if you look at the last digit, like I was doing on the other slide, if it's even, then you know it's divisible by 2. So this is some strategies for looking at the ones place. We know that digits that are divisible by 5, they end in a 5 or a 0. A 10, we know they end in a 0. These ones are pretty common. Some other tricks, if you look at the sum of the digits, so for 3, it's divisible by 3 if the digits add to 3. So if you think about 15, we know is divisible by 3. Well, the 1 plus the 5 is 6. We know 6 is divisible by 3. So when numbers get super big, maybe like 39, a lot of kids think that's prime, but we look at what those add to. 3 plus 9 is 12. I know 3 goes into 12, so that's 39 is divisible by 3. If the sum of the digits is divisible by 3 and 2, so say 12, it's also divisible by 6. If the sum of the digits is divisible by 9, then this is 1. Look at the last digit. If the last two digits form a number divisible by 4, and the last 3 digits form a number divisible by 8. So play around with that and have that written down somewhere. All right, here's for you to try on your own. If you are using the template, then go ahead and list the factors for each of these numbers, like I did on the other slide. If you are in your notebook, you're going to have to copy these down in your notebook first. But then I want you to determine if it's prime or composite. So we are going to list the factors, prime, composite, or neither, if any of them are. And then don't forget to include this. Thanks. Have a great day. Look back over your notes if you need to. Rewatch any sections. Don't forget to be awesome.